All right, let's just jump right into it. If you're building any kind of serious AI system, you're about to face a massive decision, probably around 2026. And it's a fundamental choice that's going to define pretty much everything: the cost, the reliability, and the sheer power of your AI for years to come.
And that choice really boils down to this one big question. What's the right brain for your AI? Should it be built around these autonomous, free-thinking agents, or should it be based on a library of super reliable deterministic skills? Now, these are two totally different ways of thinking about AI, and today we're going to unpack what that choice really means.
So let's start with the big one, the vision that really captures the imagination, right? The promise of a truly autonomous AI. This is the world of AI agents. So, what even is an AI agent? Well, think of it this way. A normal program follows instructions. An agent is different. It's proactive. You don't give it a to-do list. You give it a mission, and it figures out all the steps to get there completely on its own. It plans, it makes its own decisions, and it learns as it goes. No script required. And this whole idea scales up brilliantly. You can actually create entire teams of these agents, each with its own specialty, and have them work together just like a human team would. You know, one agent could be the data guru, another one handles all the comms, and a third is the one actually doing the work. Put them together, and you have a multi-agent system that can tackle unbelievably complex problems. It's a huge, ambitious vision. But, and you knew there was a but coming, right? This incredible autonomy, it comes with some really severe and often hidden costs. The reality of using agents out in the wild is just way more complicated than it looks on the surface.
And that brings us to this really crucial idea, the unreliability tax. See, agents are probabilistic, which is a fancy way of saying they're unpredictable. They might not do the same thing twice. So this tax is all the extra money and time and engineering headaches you have to pay just to make sure they don't mess up or go completely off the rails.
And trust me, this tax is very, very real. The hard numbers show that a single agent left to its own devices can cost you anywhere from $5 to $8 for one task. Why? Well, it's something called quadratic token growth, where the cost of the conversation just spirals out of control with every single thinking loop the agent takes. And that leads to this awful trade-off. For any big company to actually trust an AI, it's got to be right more than 95% of the time. But to get an agent to be that reliable, it has to use these reflection loops. Basically, it has to stop and think for a while, and a while can mean 10 to 30 seconds. That's a total deal breaker for a real-time app. So you're stuck choosing between an AI that's fast but unreliable, or one that's reliable but so slow it's useless.
And these right here, these are the specific gremlins that make up that unreliability tax. Agents can just make stuff up, hallucinations, or they get stuck in endless loops. Sometimes they even forget what they were supposed to be doing in the first place. And all of this can lead to runaway costs. These aren't just rare bugs, they're fundamental problems with the agent-only approach.
Okay, so if the whole agent thing is that risky, what's the other option? Well, let's flip the script and look at the total opposite, the practical, predictable, and frankly powerful world of AI skills. I want you to think of an AI skill like a perfectly crafted tool in a toolbox. It's a small, self-contained little program that does one thing, and it does that one thing perfectly, every single time. So instead of asking an agent to invent a workflow from scratch, you just give it a whole library of these atomic skills to pick from. And the best part, each skill already has all the rules and safety checks baked right in. And this slide right here gets to the absolute heart of the architectural choice. Agents give you cognitive efficiency. They're amazing at thinking through brand new, messy, ambiguous problems. But skills, they give you token efficiency. They are optimized for doing the same thing over and over, thousands of times, where every single penny and every millisecond is critical.
And the data on this is just, wow, it's staggering. Research shows that if you take one of those complex, multi-agent systems and basically compile its abilities into a library of skills for a single agent, the results are just insane. You slosh your token costs by about 54%, and you cut the latency, the wait time, in half. It's a huge efficiency gain.
And when you're talking about reliability for critical, must-not-fail tasks, it's not even a contest. You know, a complex agent might be aiming for 95% accuracy with a long delay. AI skills are designed to hit over 99% accuracy in under 2 seconds. For anything involving compliance or core business functions, that's really the only number that matters. So, great. The skills approach seems perfect, right? It's cheaper, it's faster, it's more reliable. Case closed. But, as with everything in tech, there's a catch. The skills-only approach runs headfirst into its own very serious scaling problem.
So the critical question becomes, what happens when you go from having a handful of skills to having hundreds? You'd probably think performance would just get a little bit worse over time, right? Well, that's not what happens at all.
Instead of a gentle decline, you slam into a cognitive wall. The AI's ability to pick the right skill from a big library doesn't just dip, it goes through what's called a nonlinear phase transition. Now that's a fancy term, but all it really means is that its performance doesn't just get worse, it completely falls off a cliff.
And this chart shows you that cliff perfectly. Look, with a small library, say 20 skills, the AI is over 90% accurate at picking the right tool for the job. No problem. But once you cross this invisible line, somewhere around 50 to 100 skills, the accuracy just plummets. By the time you get to 150 skills, it's basically just guessing. The whole system gets overloaded and becomes unreliable.
Okay, so now we've got a real dilemma. We've got agents that are brilliant but expensive and flaky. And we've got skills that are efficient and reliable but they can't scale. This brings us to the synthesis, the elegant hybrid model that solves this conflict and really points to the future of enterprise AI.
Here's how it works, and it's actually pretty simple. When a request comes in, a high-level orchestrator agent does what agents do best. It figures out the goal and makes a plan. But, and this is the absolute key, it doesn't try to do the work itself. Instead, it delegates all the individual steps to that library of pre-built, super efficient AI skills, and then they execute the plan reliably. And this model is just so powerful because it truly gives you the best of both worlds. You get the flexible, big-picture thinking of an agent, but you combine it with the rock-solid performance, the low cost, and the safety of deterministic skills. So the ultimate takeaway here is pretty clear. The future isn't about choosing agents or skills. It's not a zero-sum game. The winning AI architectures are going to be the ones that use them together, orchestrating them intelligently to get that perfect balance of power and pragmatism.
And that leaves us with one final question for you to really think about. As you're planning your own AI strategy, are you designing for raw, untamed cognitive power, or are you building for the economic and operational realities of actually running it at scale? Because as we've just seen, the right answer is to build for both.